Hi, and we just doing the video demonstration of the assignment titled Network Security Fundamentals, and it's about the network scanning and protocol analysis. So for the first part, Daman is going to start from the environmental setup.
Yeah. Hi everyone, my name is Daman. So I will quickly cover the lab environment and the IP addressing used for the Nmap exercises. So we use a virtual box with a host-only network and all the VMs. They are isolated on a single private subnet for the safe testing. The attacker machine here is a Kali Linux and our targets are Metasploitable and the Ubuntu servers and the Windows 10 and 11. Here, I have included a simple network diagram on the slide. As you can see, for this lab, the IPs were assigned for the Kali attackers, Metasploitable 2, and the Windows 11. Next, I would like to call Yusuf to continue.
Hi guys, my name is Yusuf Timal Sina. I'll just summarize the commands we ran and some of the important outputs. First, to port discovery. So we ran an initial TCP scan, and with this list open the TCP ports and attempt service version detection on the target. We captured this initial output, and as you can see in the screenshot, to demonstrate the changes, we stopped services on the target. As you can see in this screenshot, the code goes like this: nmap slash st dash p 12000 and something like that. And also we ran the same scan to show ports closing after starting also. And you can see before and after differences in our screenshots, which is just attached in the file. And for OS fingerprinting, so is this for the OS fingerprinting, we use the nmap to fingerprint the target operating system with the dash O option, and also which attempts to identify the target OS and the kernel. For the vulnerability scanning with nmap, it actually shows how to perform the vulnerability checks using nmap's NSE scripts, explains the results, and also suggests the fixes. And also these scripts written the findings and suggested mitigations. For example, patching SMP vulnerabilities or disabling the features, and something like that, like SSL or TLS scripts, which shows the example with the output and references the file names. So finally, the ethical note: all scanning was done on our isolated host-only network with VMs are controlled and the scan systems without explicit permission. So this is the complete part one, which we did in our report, and it's also shown in the whole report. I'll just pass it to Noreen and Matthew for the part B.
Okay, thank you, Yusuf. For part two, I will share screen. Yeah, for part two, we have the Wireshark and CAPTCHA for protocol analysis. So these two are different tools that we use. Here's a table to show the difference between these two. We've tested them in one in VirtualBox Kali Linux and the other one in our host Windows OS. For the host OS on Wireshark, first we use a command prompt to ping for google.com to start network traffic so that our Wireshark can detect and capture these packets. In the Wireshark, we can see that we have filtered for TLS, which is the HTTPS protocol. When pinging google.com, we can see that it captures DNS as well for domain names, resolving domain names. And lastly, it also uh, captures TCP, some of them inside the network traffic. This is for reliable data transmission, making sure that uh, the connection is secured, and so there's no other breaches, security breaches that can happen. There's no ARP protocols, and there's no ARP traffic protocols, maybe because the host OS already knows the MAC address, because it already used Google before. Next, we tested it on Kali Linux virtual machine. As you can see from this image, we've pinged google.com as well and used Wireshark. We can see mostly uh, the protocols that has been shown here is mainly the ICMP instead of TSL or TCP from the host OS. So that's the main difference. There's no TCP packets that were recorded from using a virtual machine, but there are DNS protocols, and there's no TLS, but there are a few ARP protocols as well, which is address resolution protocol, because it's a isolated subnet on the virtual machine. Next, I would like to pass this on to Matthew, who will explain the CAPTCHA on host OS.
All right, no worries. Thank you very much for that. My name is Matthew Goszkowski, and I'll be talking about the CAPTCHA on host OS. So after pinging google.com, CAPTCHA captures the traffic and presents it in visual dashboard. So what stands out is the SSL protocol is detected, and it confirms a secure connection. This makes sure it's reliable and that there are no problems of delays. And CAPTCHA provides a summary table with MAC address, packet counts, and other metrics. The summary table obviously makes sure that there's good structure, that everything's done in the right order, and it is also beginner friendly for visualizing traffic patterns, which is very convenient. All right, so CAPTCHA's graphical interface makes it easier to interpret data compared to Wireshark's packet level view. And that will be it for that.
So in conclusion, we learned that Wireshark is good for packet inspection and protocol debugging, and CAPTCHA offers like visual representation to make it easier for beginners to use. And that's it. That's all for our presentation for BN200. Thank you.
Thank you.
Yeah, thank you.